circuit with a given resistor, inductor, and capacitor. So let's try it here. What we have here in the first line we have a resistor and the inductor are in the series. In the second one is a resistor and capacitor is in the series. So let's go first with the impedance that happened in the first line. We have a Z1 is equal, so because it's in a series, so we have the addition between the resistor and the inductor plus XL. But now let us write the Z1. Let us write with the just with the numerical values without units. So this is a 3 and is a plus. When we have for example, when we have the inductor, we can write a 5. I is imaginary number. We are writing with respect to the complex numbers. And now Z2 in the second branch is the resistor and capacitor are in series, so we can write R plus XC. So we write in with the denotation whatever they are there, and Z2 is equal, now the resistor is 4. I'm not, as I said, I'm not writing the units, is but instead of the plus here, whatever sign is, I'm going to take the opposite side, and is minus 2i. So I'm writing in terms of the complex numbers. So now, what do I have here? Now, those are in the series, and now we can create another circuit. Here is the impedance 1 and impedance 2, but those are parallel. Because those are parallel, I'm going to find it with a different way. 1 over Z is equal with 1 over Z1 plus 1 over Z2. So we can set up the equation this way. Z1 plus 1 over Z2. And now I want to find the LCD for both, for Z1 plus Z2. The LCD is, I multiply this by Z2, but whatever I multiply down, I multiply up in the fraction, Z2, and here I multiply with the Z1 because I want to make the same denominator, times Z1. And now 1 over Z is equal with, so now I am solving this expression. I'm adding these two fractions, which is Z1 times Z2. And Z2 times 1 is Z2, right? Z2 plus Z1. And I am flipping this fraction, and Z over 1 is Z, and it's going to be equal. And on the top I have Z1 times Z2. And here the commutative property works, so instead of Z2 plus Z1, I will write Z1 plus Z2. Nothing is going to change. So Z is equal. Now instead of Z1, Z2, I am writing those values, numerical values. And I'm going to have this way. Z1 is 3 plus 5i. 3 plus 5i. Instead of Z2, this Z2 here I am writing, but it's multiplication, so don't forget. Let's write a parenthesis. And Z2 is going to be 4 minus 2i. 4 minus 2i. And I close the parenthesis. So Z1 here, as I said, here is 3 plus 5i. 3 plus 5i. And Z2 is 4 minus 2i plus 4 minus 2i. plus 4 minus 2i. And now z is equal. So now I'm going to distribute the multiplication in the numerator. And 3 times 4 is a 12. And 3 times minus 2 is minus 6i. Minus 6i. Now 5i times 4 is a plus 20i. And 5 times 2 is a plus, I'm sorry, it's a minus 10i. Is minus 10i. Let me extend this fraction here. Here, 3 plus 4 is a 7, so here simplifies. Minus 5i, minus 5 is a plus in fact, but I forgot to write plus. Plus 5i minus 2i is plus 3i. So when we do a long calculation, sometimes it's easy to make a mistake because we get tired of multiplying everything. And this is a I square was, because 5 times 2 is a 10, negative 10, but I times I is a I square. But this I square is a minus 1. I square is a minus 1. Now, minus 10 times minus I, instead of I square is minus 1, is a plus 10. Plus 10 and a plus 12 here. So real numbers with real numbers. And z is going to be equal with 22. 22. Let me extend to this line here. And now minus 6i plus 20i is plus 14i. So now I have a very short or very simple, but we have to simplify further because we want to rationalize the denominator. We don't want the denominator to have a I. And what we are going to do, we are going to multiply with the conjugate of 7 plus 3i. And the conjugate of 7 plus 3i is going to be 7 minus 3i. And we are going to multiply with this conjugate. And 7 minus 3i. If we are multiplying everything, then z is equal. 7 times 22 is 7 times 2 is 14, 4. 7 times 2, 14 plus 1 is 15. So this we were able to do it. And plus 7, 14i. Okay. 7 times 4 is a 28. 7 times 1 is 7. Plus 2 is 98i. I have here. Minus 3i times 2 is a minus 66i. So this was easy. Minus 66i. And now I have here minus 3 times 14 is a negative. 3 times 4 is a 12. 3 times 1 is 3, plus 1 memory is 4. 42. Let you write this for better because in the long run I can forget. 42i. And 7 plus 3i is going to be 7 square. Is going to be minus 9i square. But I square is minus 1. And minus 1 times minus 1 times minus 9 is plus 9. But first of all, let's go here. Let's write with a different color. And z is equal. Let's see if we can simplify further. But here just we forgot something, because when we multiply minus 3i times 14i, here is I square. And I square is minus 1. Minus 1 times 42 is 42, positive 42, and a plus 1, 54. We have to add them. So it means that 2 plus 4 is a 6. So I added the first number. And 4 plus 5 is a 9. Okay, it's 196. And what do I have else? I have a 98i minus 68. It's minus 66i. 8 minus 6 is, but it's going to be positive because the positive number is greater, is a 2. And what do I have else? 9 minus 6 is 3. 32i. Okay, we are here. We are here. And just me make sure nothing is wrong with this example. Okay, let's go further. And now 4 square is 49. 7 square is 49. And it's plus 9. That's what we have here. And now z is going to be equal. Everything down, just let me go to the last calculation. 49 and 9 is 18. And is 58. And this one is 186. 196 plus 32i. I just made 6 is everything here correct? Yes. Yes, yes, everything seems is correct. And now z we can write as equal 196 divided by 58. 196 by 58. And the other part is going to be plus 32 divided by 58. 32 divided by 58. But this is I. And in the end, if we want to get the decimal numbers, and if it's not a big deal, so we can multiply we can use a calculator, we can divide those numbers, we can have a decimal numbers, which is 196 divided by 58. And is equal to 3.8, let's say. So z here, z is equal to 3. Just let me see again, because 3.338, okay, it's a 3.38. 3.38. Here the sign is a plus, and we can take this 32 divided by 58. Let me divide the last digit. 38 divided by 58 is 0.66. Yes, 0.66. So I am truncated in 2 decimal numbers. And that's it for this example.